Let's run it again. Hoping you're all hearing that. If you're hearing what I'm hearing, it's the sound of velocity. Right here, we're doing the overall speed. And this, we're basically the lower pitch is lower velocity. So also where this object is blue, it'll start lower pitch, and as it picks up speed, it goes higher pitch and velocity as the velocity increases. A simple way to do what our lesson is called today called Auralize. Auralize, make audible the velocity. Yesterday on day 25 we did of 30 days of symmetry, we did visualize velocity, which is this number system in this color trail, and today we are just adding another little piece of that, to go a little bit further and kind of build on it, which is to auralize a piece of audio and auralize the velocity, get a piece of audio, and you can actually see them right here getting emitted and played, and then they get pitch shifted based on the velocity of the ball. And this is one example of a way that you can kind of dynamically change the audio properties. One of the funnest ones is shifting the pitch using the transposed pitch, which we're going to do today. But you could change the volume, you could change any number of properties on the audio, the reverb or whatever, at the moment that you emit it into the space and play it. So it's a fun way to start to kind of dip your toes into all the things you can do with audio in Simmetri, and we'll basically reconstruct this and create this system where we get to hear the speed of this object. One of the things that I've got going on, so let's take a look at the scene and then kind of unpack what's going on here, and then we will we'll dive into the code and the kind of procedure for setting this up. One of the things that I've got going here is that I've got a little, if you click on the ball itself and click on the rigid body, there's this thing called constant force, which you learned about using under Learn Physics Anti-Gravity, actually. And this is a constant force that's separate from anything else, forces that are getting applied to it by gravity or any bounces, but this is just something constantly, steadily pressing. And this one's heading in the negative z direction, so that accounts for this ball starting off here and getting a little bit of push, and you can see it making these bounds, these sort of steady jumps. And yes, it starts here, then it goes lower per bounce. And this thing is also very bouncy. It's at 0.95 bounciness as opposed to 0, which is the default. So it is bouncing pretty well, but it's also making greater leaps each time. And each time it's getting more of that constant force is kind of taking a part in its physics. And so that's this negative value in the z direction. And I did that just so that when the ball fell, it would start to kind of create an arc. Without me having to touch it or something else having to kind of knock it around. And so you can see that play out when I press play. It moves off to the side. And I can actually dynamically change that constant force. And now it's coming back to me. I can slow it back down, switch it around. Anyway, that is one of the ways that you can kind of, this is fun to play with, and I was just showing you why it's working that way. So that's actually, I've put a positive force on the y, in the y direction on the rigid body, which counteracts the gravity. If I click on the ground and look at the physics and look at the expand physics and gravity, I can see that we're at negative 9.806 is the gravitational force, and I've got the ball now counteracting it with a positive 6.6 or so in the upward direction, which means that it's actually falling slower, given that it has that force. And it's picking up less speed ultimately. So it's gravity's sort of taking a slower process with it. Too much fun, honestly. I can't help but like look at this and hear this and just think of a lot of different fun things I would like to do with this, and the other things I would like to auralize, make audible. And one of the things that we were doing yesterday was switching between the overall velocity vector, the overall magnitude of the velocity, which is speed, the speed in any direction, and switching it over to just speed in the y direction. And that was by changing kind of the code to be not looking at the velocity, the linear velocity's length or its magnitude, but looking at just the dot y value of that, the y component of that velocity vector. And so you could do that. There's other things that after the end of this tutorial, you'll be able to do is maybe auralize just the actual height of the ball or its position in the x and y direction. You could also change, using what you've learned in some of the other tutorials, calculate the distance between this object and some other object. And as it gets closer, it could get higher pitch or lower pitch. And you already know how you might dynamically change something's color based on those values as well. And so let's take a look at what's new in this show, and then we'll build it we'll build it up from kind of the end of yesterday's tutorial. Great. So the main thing is that we have an emitter that emits sound. Yesterday we had this. This is our ball. This is the ball with its rigid body. And I've got that constant force on it, and it is the one that is falling, and we're sort of we have all these things connected to it, which are emitting like a colorful tracer and changing the color based on its velocity, and also putting behind a label that is the overall speed, or whatever we want to we basically are treating it like a speedometer, these little numbers that follow behind. And so that was basically the ball, the tracer, the label, and the speed emitter. So the tracer emitter emits the tracer, the speed emits the speed. And we added a new one called this sound note emitter. And what it's doing is emitting, and you'll see these little purple things right here. It's emitting the sounds, and it emits the sounds at a certain interval. And just like we did with the tracer, I'm not going to actually edit the code. I'm going to look at the properties of the tracer emitter. That emitter, if you recall, isn't emitting on a constant pulse. Its constant pulse is set to active false, which means it's not emitting on a time-based interval. It's emitting on an area-based interval, which means that as it moves, it's going to emit 4 tracers per meter, per unit. So it's emitting 4 tracers per meter of movement. When I put in the sound item, I thought, it would be interesting to try a few different things, and I kind of settled on also doing the emit rate being moving as opposed to on a continuous pulse. And I liked it actually spaced out to more like 2. It felt like there was too much going on when I put it up to 4. I'll put it on 4 now. Actually, as it goes slower, it's not so bad. But when if I get rid of the constant force and set this constant force down to 0, double clicking this roller to set it to 0. It's not bad. You could, this is something we'll be experimenting with, but anyway, that's where we're controlling how many little pieces, how many little copies of the sound get played into the space. And so you can think of this emitter as emitting a new version of that sound clip from a source sound clip, and then it's emitting two. Was I changing the tracer? So the tracer's emit rate is 4 per distance. I'm going to change the emit rate of the sound to be 4. I'm not sure I changed that. I might have changed a different one. It's not bad. So this sound emitter is emitting 4 of those sounds, or it can be 2, and we still, I think, will be fairly happy. And then all it does is it has this little single line of code on it, which just tells me that the object that's getting emitted, which in every emitter on the on-emit event is called OBJ. It says obj.transpose pitch, which is a property of the sound, and we'll go look at the sound here. And then it just goes and does what we did on this, to change the color, we go and we get the parent node, which is the ball. We get its rigid body, which is its physics representation. We get that linear velocity, and that's a three-dimensional vector. And when we get the length of that, we get the magnitude, which is the speed. And then I just sort of found some scalar value that I multiplied by to kind of get the pitch into a range that was pleasurable. So this is sort of the mess around with this number until it sounds, to your liking. If we change that to 2, we'll get a different sort of mapping of speed to pitch. That's actually pretty nice. I like 2, honestly. Throw it off into the distance and away it goes. So let's take a look at so we should be now in a place to, now that we kind of know what we're building, let's go ahead and create this. What I'm actually going to do is just delete away these items, and you're going to see how it kind of comes back in. I'm going to delete the sound, and I'm going to delete the clip that it's associated with. Deleting this and deleting that. And now this ball just drops, and this is basically where we left off on day 25, visualize velocity. And it's pretty, but you can't hear it. And already it feels like I just put the thing on mute. I mean, duh, but how awesome is it to kind of add sound into your world and into your landscape. So what we need to do to bring in audio, just recenter. I'm going to fly to the sphere. What we need to do to bring in audio is import an audio clip, and I worked with a particular one that I liked, and let me bring it up here now. Under my assets in my audio clips, and it was under, I got it at Free Sound, and it's this AIF file. Well, I guess in VLC. Give her a second. You could use pretty much anything, but I think that's fine. Will it play? Am I not getting the audio? Tim Kahn cello. Let's go find it. I'll tell you exactly how to get to it. We're going to go to edit, find, and then this will launch you out to freesound.org. And I thought I'll take something that's kind of at the vocal range. So I'm actually going to work with sort of like a cello or a viola or something. So I just chose cello. What I'm looking for is something that's kind of that has some overtones. As you shift frequencies, if you use like a pure sine wave, it can sound super crazy. I wanted something with kind of a warm overtony sound, as well as one that has kind of overtones that don't kind of stack up and create weird positive interference. So that's just something that I kind of knew that I wanted to kind of a negative side effect of using a pure sine wave that I didn't want to use. I also wanted it to be something that, and we'll go and look at these on Freesound. I'm going to click cello, and then we'll pop up our browser. I'll close down some other tabs. So if we look at Freesound under cello, we'll see a number of these, and we could test there. What I want was something, I didn't want to have to make an edit to it, but you certainly could. There would be nothing wrong with editing it, but you can see that some of these have this little clip. They have this little like header of like no sound, and I wanted something that played immediately because I didn't. But if you wanted, you could just edit and kind of cut this clip out. I just want that when my sound gets emitted in my space, when as the ball drops and it emits that sound, I want it to not be waiting. I want it to be like instantly playing sound, so that there's like instant feedback, and it's not. I don't end up kind of with this weird sort of delay. I want everything to kind of start. So my first criteria was, like I said, something kind of warm with overtones. My second criteria was something that I didn't have to edit, that would play immediately. This one plays immediately, but I don't really like its sound. And the last one would be that it would be kind of short and like singular. That's not short and singular. This is neither short nor singular. I think this is the one I just tested that has too much of a header. That one also has a header. And that's a loop. I'm trying to think, which one did I go with? I think it's this one. Yeah, it's this one. It's pluck. It's this plucked sound. Pizzicato multi-sample by Tim Kahn. So if you want to kind of recreate exactly, also thank you Tim Kahn for uploading this. Old cello pizzicato CS cello A3.AIF at freesound.org. So this is the one I'm using, and Simmetri will bring in an AIF and convert it and get it ready for playback. So the way that you're going to import that audio is go File, Import Raw, and then I'm going to go to Assets, and I'm going to go to where I imported it, or where I stored it, which is under Audio. I go Clips as opposed to Music, Freesound, Tim Kahn, and then press OK. And you'll see that it brings in what's considered an audio clip file, and when we bring that into the world, it creates what's called what's known as a sound object. So we can bring this. We're going to drag this object into the world. Just one thing to keep in mind: by default, loop is set to false, and technically, at least for my example, it stays false. If you want to test your luck and go crazy, see what happens when you start looping a bunch of these. So I'm going to drag this object into the space to create a sound object, and that's this little purple character, this little purple guy down here. And if I look at its properties, I could change its name if I wanted. That could just be like cello pluck, for example. If I wanted, it doesn't ultimately matter. I think one thing that if you were bringing in a bunch of sounds, you might want to remember which ones. If you have to do Creative Commons attributions, you might want to just kind of keep track of which ones you brought in. So this is the cello pluck sound, but you will also be able to keep track here because it is the sound is the spatial property representation, kind of the spatial layer of how this audio clip interacts with the world and the microphone that is attached to the camera that's listening to this. And so this sound is the sound file, this purple, is different than this little clip. So think of the audio clip as having a spatial embodiment, a wrapper of properties that's basically this sound object. And on this sound object are a variety of properties. For example, the ultimate volume gain, which is just the overall volume switch. Inner radius is this is the radius at which if I'm near it, as I get closer and closer and closer to this sound, when I get, at least when inner radius is 1, as soon as I get to anywhere inside of 1 meter, this audio will be playing at its full gain value, its full volume. And then the drop-off slope is the slope at which it drops off. And if I'm not mistaken, the longer slope means it's a shallower drop-off. Out, and like that goes out from the inner radius. So the inner radius, anything inside the inner radius, will be at full volume. If you want to take an idea of what this should look like, picture around this object is a cylinder of audio at full volume. Anytime you're in the inner radius, the radius then being this, the inner radius. Once you're inside this, everything is a constant volume. It'll all be 100. It'll all be one at the full volume level, and you can imagine like a cone of sound doing a drop off, something like this. And then I'll just change this just to visualize radius 1, like so, something like that, and then height being like there. So this is just a kind of a crude visualization, but around this audio clip, inner radius is the point at which it's at full, and then there's this drop off, and this slope is related to this drop off slope, and a longer one means it drops off more slowly. And so that's the volume drop off slope, the inner radius. I'll get rid of this little diagram for you, and then there is this value, which is which timeline is it playing on, and we're going to ignore that for now, but you could be playing it against a different timeline. So if that timeline is slowed down, or if that timeline is inactive, this audio will be playing relative to that timeline. So we won't worry about that. We're just going to leave it as default in the terrain space. We're going to leave reverb where it is, but you can mess around with all these different settings for reverb. I'm just going to actually leave it as default. So don't touch reverb. Autoplay is the one that we're going to be working with. But autoplay is kind of really where you're controlling. This is kind of one of your main controls about how you're going to access this sound file and make it play something. And there's the only one when it's off. You're basically gonna your options to access this are through script, and we're not actually going to access ours through script. We're going to access. We're going to make this thing play the clip by when it gets copied, because it's going to come out of an emitter, which is the equivalent of being copied, and so that's an option here. And I'll just let you kind of understand how on the timeline works, which is that if I get in here in the inner radius and I turn up, or I won't turn up the volume, but it'll play on the timeline, and you can actually see it here. It's written out here because autoplay is on timeline. If I go to off, you'll see the track disappear from here. If I go back to autoplay to on timeline, that means when I press play, it's gonna live on this timeline and play when this timeline starts and match the time to this timeline. And I believe this should work, that if I press play and move the time scale down, so if I move the time scale to 1/4 and press play, we get this much lower sound. If I move it to twice as much, so let's say 2x should equal like a full kind of octave in this case of so 2, we're at the time scale under on the timeline under terrain space. So that's the timeline kind of controlling this audio, and you can see that it's actually changing the pitch. That's the consequence of just audio and time and stretching the frequency. So what we want to do, so that's the timeline. So that's how when you autoplay on timeline. Off again is accessed by script. On active would be this situation where I make active false, press play, and then and it goes active. So this is kind of a technique where you might make it false, and then you do add a key track and do a number key track and make these little events where you want it to go from active to true. That's active false. It's active true, and that's active false. So you get that effect of like just activating that audio. So that's the autoplay on active, and on move is pretty cool. Let me get rid of that audio track there, and let's make sure that this one is active to true, and we're going on move. So if we press play, we're not moving, but as soon as we move, we'll start. As soon as that audio plays out, we'll and completes the full length of the clip, we will be able to play it again. So that's and then on proximity is interesting when you get within the inner radius. So the inner radius is 1 meter away. So this is a nice way to sort of build like ambience, like a whole network of ambience. So as I come up to it, I got within the inner radius there I had to kind of, it looks like I walk over it, but that triggers it. So you could have a whole kind of audioscape built in such a way. In fact, if I make a bunch of these, you'll see that as I get close to them. And if I change the inner radius, so this one is when I get 7 meters away from this first one, it'll play, and then the others will be 1 meter away. So I got 7 meters away from the cello there. There you go. So that's a fun one to play with. Is that I'm going to delete these away, those extra ones. I'm going to set this that inner radius. That's fine if that stays at 7 meters. But that's fun. The on proximity with inner radius, you can build up, like I said, a whole landscape of stuff. And obviously, just clicking a pluck. But you could see, having a narrator and a music track, and if you kind of faded them nicely, or if you controlled the volume. Here, this gain, and you control this to be something to ramp up. There's all kinds of things that you could do to build an entire kind of audioscape, and this is just a little peek at what that looks like. Okay, so that's the overall basics of all of this up until the what we're going to do with it, which is to work with transpose pitch, and our thing is going to be active on copy. But let's just actually work with let's do the, when it's on timeline, it won't do transpose pitch. So if it's on copy, it can work. And if, for example, we transpose the pitch some, and then we copy this by holding down Alt, and then we transpose pitch. The way that transpose pitch works, and this is going to be the crux of what we're working with today, and today we're not going to actually get too focused on like musical kind of music theory, or even kind of chord theory or anything like that, really. But we're just going to be transposing the pitch kind of on a continuous scale. As we copy things, we're going to change this pitch value, and this is basically like our hue yesterday. As we copy, we keep kind of moving this along, and if our audio if our velocity picks up, this thing's going to be higher or lower depending on how we kind of want to work the math. But we're not going to necessarily try to figure out the exact velocity to make say like a C440 or something like that. The thing to note is that this audio clip came in as an A3. I think that's indicating the which note that is that's plucked. And the way to think of transpose pitch is it's a semitone, and you can see it here in the helper. It transposes the pitch in semitones. So 12 semitones in a like a semitone octave scale. So if this goes up to 12, let's actually so let's play it, and it's autoplay on copy. So let me go ahead and just copy one, and so that's its normal sound because we're transpose pitch is 0. 0 will be normal, and then 12 will be 1 octave up. I'm reaching back at this other one where the transpose pitch is still 0, and this one's transpose pitch is 12. And so those are all copies I made that they'll all stay here in the space, but I can delete them after the fact. When I go ahead and copy them as an editor in playtime editing, they're going to stay in the space. When they get emitted out of the node emitter, it's the node emitter which goes and cleans up the old ones based on how many it is allowing to live in the space, so that infinity don't end up in the space. So that gives you an idea of how transpose pitch works. So how many half steps up from your note. But then we're just going to basically kind of move up these, not in semitone steps, but you certainly could if you sort of work with integers. So 1 would be one semitone up from your note. So 0, then 1. 2 would be basically a whole step, if you think of it in the sort of that way of half step, whole step. 2 would be a whole step jump. Play it. That's 2. But we should go to 7 on that, or 9 rather. Excuse me. Anyway, so you get the idea there. So let's set this up. A lot of this is just giving you a familiarity with audio. The ultimate implementation of this is fairly easy once you kind of know how to understand how audio is all working, right? That there's this data file, this what's considered as an audio clip, which feeds the spatial representation of that, which is this wrapper of sound, which has all these properties which can then be set dynamically. And then there's this autoplay kind of regime, sort of how do I want to manage the way that this audio gets played. That's all controlled under autoplay. And today we're using onCopy, but if you want to just be accessing it through script, calling the play event, you could put this to off. And then it's up to you to call the two functions on it. So cool. So we're going to be using copy, and we are going to be emitting. We're going to be emitting this object from our ball. So right now, our ball falls, and it's got this tracer emitter emitting tracers, and it's got this speed emitting these little speedometer nodes. And it falls straight down, and then it comes back up as it bounces, and the color follows the velocity. So let's just take a reminder of what we did under the tracer node emitter to kind of see what we might be doing under a sound emitter. What we did was we just basically set a single property on the object obj, which is the thing getting emitted. We set the dot color value, and then we just set a hue, saturation, brightness. So an HSB function. So passed into the HSB is a hue value, a saturation value, and a brightness value. So you can see 1, 1 is the brightness and the saturation, which is really not what we were changing. All the guts of what we were changing is really based here. And then we did some math around the self get parent node, get rigid body, get linear velocity length. And just to make this show you how easy it is to kind of build up from where you are, I'm going to just hit copy on this. I'm just going to select this. I'm going to Control C. Then I'm going to come over. I'm just going to hang on to that because I'm going to create a similar on emit event on a new emitter. And so I'm actually going to model my new one after this tracer because we have the emit rate at 4, and we have we're not going to be emitting on a constant pulse is going to be set to active false. So that means we're not going to be working with a constant pulse. We could also select none here. So what we're going to do is clone this tracer. I'm going to hold down Alt, and I'm going to grab the tracer and throw it into the world. Then I'm going to drag it back. Then I'm going to change its name. I'm going to change its name to sound node emitter. Then I'm going to grab by its words, and I'm going to drag it back up over ball so that it be childs to ball. So now it lives as a sibling of speed and label and tracer node emitters. And the sound, now we just need to swap out what it's looking for. It's looking for the cello pluck. So what we're going to do is go to the properties of our sound node emitter, and we're going to go to pick our sample, and we're going to pick, and we can try to select it out here in the space off in the distance, but we can also select it right here, which is easier. And so I'm going to choose to select it here. Oops. Excuse me, I clicked and dragged, unfortunately. Excuse me, so let me go back. I'm on sound emitter, and on cello pluck, I'm going to hit pick, and then I'm just going to click cello pluck. And you can now see that it says cello pluck instance is my sample, which is great, which means I'm now going to emit 4 of those sounds every meter that I travel. And this thing travels a meter every time the ball travels a meter, right? Because it's living on that ball. The other thing is that when we dragged it back onto the ball, it's not in the center. You see it sort of off to the side. So we need to be mindful that when we child and we want things to be on the center, we need to take the transform and set these all to 0 so that we go to the 0 origin of our parent, which is our parent's center. And so now we have the sound node emitter at the center of our sphere, and it has the sample of our cello pluck, and it's going to emit 4 of those per second. The last thing to note is that these samples are being cloned as a copy, and this is kind of key with the audio. For the most part, you're probably going to do this. So this is a copy, not a shared copy. I believe, if I'm not mistaken, that if I do shared copy, no, they're doing okay. Shared copy is okay too. I'm gonna stick with copy for the time being. So on the sound node emitter, I'm gonna use a full copy. I was concerned that they would, depending on the way that you have these settings for the autoplay, for example, if it was on timeline or something, you could end up emitting ones that have already kind of passed their timeline, and so they're already spent, and you're not hearing any audio any longer. So in our case, we're good with the sound node emitter. We could use either clone as copy or shared copy, but I'm going to go ahead and use copy. If I was going to be concerned with having too many unique sounds in the space, and that being too much data, I could be conscious of what's our maximum simultaneous amount of sounds to put in the space. And I think there is ultimately kind of a maximum of audio that you could put in the space before your audio card will not be happy. I think Amadeo can specify that, but I believe it's kind of over 500. And frankly, I'm not sure. It just seems crazy that you would have 500 sounds active in the space. It's almost that kind of a cacophony. I can't imagine you could. I think you should probably find happiness with under 100. And if you can't, you have all the way to 500. I think that'll do. So anyway, the maximum amount of sounds that are going to be out there emitted will be 100 at any given time. It'll keep emitting, right? It'll keep emitting for 4 units every meter. But once it gets to the 100th and 101st, it'll go out and it'll delete essentially, or what's called orphan, the first one that it emitted. And you can kind of see that. You'll see this one start to disappear, right? You see them disappearing dynamically. That's as they get to that max simultaneous value. Okay, so we've got our node emitter. It is at the center of our ball. It is emitting 4 per second. It has 100 that it'll emit until it starts cleaning them up, and it's emitting as a full copy. Now all we need to do is dynamically change the pitch, and we already have an event on our we already have a on emit event on our sound. So on our emitter, our sound emitter, like all the emitters, at the very bottom has this thing called events, and under it, it has like many others, init, tick, and on move. But it has this really specific one to it, which is the on emit. and it came in, since we cloned this one off of the tracer, it came in with the tracer's, can actually, if I think, maybe I can undo to get there. Nah. Just like the tracers on emit code, it came over with this stuff, with the stuff about the parent's velocity, and it had this, which we basically copied away. But I'm going to basically, since I had copied it, I'm going to edit code, and I'm going to I'm pressing Control V. Our thing's been on the clipboard there for a couple minutes. And this is the way that we, as this emitter, we go get our parent, get that parent's rigid body. We get our parent gets its rigid body, and it returns its linear velocity, which is kind of an internal value, which is a three-dimensional vector. Then we do length, and we get speed. That's the speed, right? So we could basically say speed equals this, this value. And then I can basically say something quite as simple as, I am a sound emitter, right? I'm the sound emitter, and I am emitting copies of this. The thing that I'm emitting is my, in my onEmit function, is referenced as obj. So obj is this sound object. So if I go obj dot transpose pitch, I can set the transpose pitch dynamically. Based on the speed. So if I go obj, which is my sound object, dot transpose lowercase t uppercase p pitch, transpose pitch, that sorry, no open close parentheses, excuse me, obj dot transpose pitch equals some value, and I could just say it equals speed. And what's that going to mean? So when our speed goes up to 10, that means we're going to go from our normal value up to 10. And remember, 12 was basically a 12 is an octave, right? So 12 is 12 semitone steps. And so you could basically think that if this object goes from its current from 0 to 12 meters per second, it'll go from its current pitch to 1 octave above its pitch. And then if it goes to 24 meters per second, it'll go to 2 octaves above its original pitch. And let's see what we get. We're doing it, and quite literally, it's fascinating. You can see, and I'll just put a little sideways thrust on this thing, like I was doing in the beginning. It actually does, in fact, get to 12. You can see it go 3, 6, 7, 8, 10, 12, and it gets to about 14 by the bottom. So it has indeed gone up an octave, which is pretty cool. So object.transpose pitch equals the speed, and the speed is equal to get parent, get rigid body, get that linear velocity, and get colon, run the length function on it, and it'll turn that three-dimensional velocity vector into a single unit vector, and then I can use that single value to toggle my speed. And you could go, so you get this. However, I could also go negative. So negative 12 on transpose pitch will take me to negative 12 transpose pitch will take me into 1 octave lower. So what's that if I take negative speed? Awesome. So I could do negative speed, which is pretty cool. Now, if you wanted to, like last time, instead of doing the length, just do the y values, like just do the change in y, you can get rid of this colon length and take the get linear velocity and just get the y component of that. How much linear velocity do I have in the y direction? Which means that if I drop from here, I'm actually going to have a negative y. Linear velocity is going to be in the negative direction, and it's going to increase until it gets to the ground, and then it's going to start surging back up, and it'll be its maximum upon reflection at the ground. It'll be maximum in the upward direction, and then it'll eventually reach 0, and then it'll go negative, which means that I should get a different, I should get a different type of sound. I should get it should go, I believe, lower and then switch to higher. So if I go to get linear velocity dot y, and then I just have it keep it as OBJ transpose pitch to speed, not negative speed. And I can switch it around too, but I believe what I should get is this goes upwards, which means I'm going to get high pitch, and then, no, sorry, it's going to be lower and increasingly negative, so that'll get me to like -12, and then I think it'll switch to 12, which means it'll go from like, they'll go an octave down, then it'll jump 2 octaves up, which is 1 octave up from the original, then it'll come back up. So let's see what this sounds like. Whoa, is that right? Wow. Oh, so what you get is this interesting, yeah, I mean, honestly, it does kind of just look like the shape of pitch. It sounds the way it looks in a funny way too, sort of, except you can hear it kind of pitching, like it goes, jumps up, and it's just, it's kind of like a sawtooth signal. Oh, and you know what else is that it blends across, because by the time I'm hearing all of these pitches mixed with all of these pitches, so that it takes time, right? So there's some time amount as I'm hearing this pitch come off, and while this, so I'm listening to a mix of kind of, you know, this many pitches. So if this, let's say that, for example, our cello pluck was like a smaller piece of sound. You remember it was like plung. If it was more like blip, if it was like a really tight blip of sound, we probably would hear like less blend across this low pitch to high pitch. But this is me getting excited because I'm like discovering this as I'm teaching it. But and you can still hear a low rumble while you hear a high rumble up here. So this is essentially the tutorial here, and I can leave you here to experiment with all kinds of different things. In fact, let's do one more, because I can't help myself. Let's change our transpose pitch to not even be our speed, but rather our just position in the y, our world position in the y dimension. So as we bounce, we're actually started up here at 12. Yeah, let's give that a shot. We'll start at 12, which will basically we'll be bouncing around an octave. Let's see what that looks like. So instead of obj.transpose pitch equals speed, we could comment this out or just leave it. We're not going to use speed in this case. We can actually just sample our self get world position. So self, which is the note emitter, when it gets its, you'll look at it, right? You'll go, oh, what is its position? Well, it's 0. Well, it's 0. Its local position is 0. It's because it's to its parent, but its global position is actually basically where its parent. It's the two kind of combined, right? So its global position is where it is in the world, no matter where it is locally. So when we get its self get lowercase g, uppercase world, uppercase position, open close parenthesis, and that's a 3-dimensional vector. We can't transpose the pitch by a 3-dimensional vector. We need to transpose it by either a unit of the get world position, or the length of that 3D. But the length doesn't really make sense. We're talking about just its height. So that's going to be the dot y. So what does this sound like? And that's fairly expected, isn't it? And what happens if we put 2 in the world? Am I going to... What if I come up here? Enjoy this. I'll be interested to see what other directions you take this, especially if you want to whip this ball around in VR. Go to interactions, go grabbable fixed, and place it on the rig, or sorry, on the sphere, and that's going to make it so you can bounce it around, and then put in a VR rig, a standard VR rig preset, and your lasers will be able to grab that sphere, and you can bounce it around, bounce it off of other objects, anything like that, and yeah, and just like I said in the beginning, this same concept for this node emitter, or other this this system of doing object transpose pitch and then passing in, putting in some value, some dynamic value or something, that you've created due to some interaction, is a great way to kind of create interesting, pitch items. And quite literally, you could set up a musical scale. You could create, you could create a lot of different interactive capabilities and kind of fun little experiences just using the transpose pitch, and how, figuring out other calculations, and you could set it equal to the time of day, and then make the time of day change. So yes, I guess I want to teach you one other thing just in case you're going to play with audio. Your sound object that kind of comes in, you the way that you would call a make this thing play in code is you're going to get the sound object, get a hold of the sound object itself, like I did, like either dragging it in or finding it through other means, and then the function that you're going to enjoy is play. It's that simple, and that'll play it. So if you have an on press event or something, you can play that event. Let's take a look. Actually, I think if I'm not mistaken, F1 over a sound. So I hovered over this sound object and I hit F1, and the Simmetri docs came up, and you can see that I have the methods of play, stop, and play shared copy. And so just wanted you to kind of see these. So the difference between play and play shared copy is that play shared copy kind of puts out and it says it here, it puts out a totally new instance, and this is and this is a situation where you want the sounds, you're emitting the same sound, but you want them to like layer over each other, and you also, if there's some sort of clone variance, that when you as you play it, there's some sort of like automatic kind of change dynamically created to it. So this is playing a unique. This allows you to kind of layer a bunch together. So work with these methods. So calling, like I said, if you found yourself putting in a sound in script, you'll just grab that object and press colon, lowercase p-l-a-y, open close parentheses, and that'll play that one. So I'm gonna save this. I'm gonna delete this second ball. I'm actually gonna delete the VR rig, and I'm gonna get rid of the grabbable node on that object there. And you should be all set to mess around with your pitch ball. Yes, so enjoy.